Hello, my name is Deborah Mille and I'm currently working for the consultancy company Creocean as a marine engineer. Creocean is one of the Pixels partners. In this video, I will present you how the air pollution model is integrated in the Pixel dashboard as a tool for Port Manager. As you can see in the port activities scenario video, Pixel is focusing on analyzing, modeling, and examining the impact of cargo handling and storage in the following areas of interest. The first one, energy consumption and production. The second, inter and multimodal transport and the environmental pollution. For these areas, the respective models have been developed, and in this video we will focus on one of the environmental pollution model. Cargo handling within ports, loading and unloading cargo undeniably involve emission of pollutants in air, water and soil, but also noise production. So, in the environmental pollution models, three tools are developed in the Pixel project. One for the air pollution, based on air emission, one for noise pollution, and another one for water and soil pollution. Harbor aspect of air quality is recognized as the current major environmental priority in the European port sector as a whole. This reflects the importance of this aspect because of its direct relationship with the health of people who work or live around the harbor. Air quality is a priority issue independently from the size of the port and of the type of the port. Based on the recommendation of the port involved in the Pixel project, the environmental pollution models are needed for two aspects. Quantify and estimate the air pollution emitted by the port, and also predict and simulate the possible future air quality situation. The objective is to create a tool for small and medium ports to estimate the air pollution emitted by a port using validated technologies. Based on existing measurement and port activity data, the model should simulate the air pollutant dispersion caused by various activities and operations taking place within the port real emission. The air pollution input data is distinguished in three categories depending on their source. The first one coming directly from the port activity scenario model. The machinery the port is using for cargo handling is very diversified. Useful information about this equipment, among others, are its fuel consumption, are its power, are its operating limitation. All other information can detail the supply chain for each ship. This, and with the use of emission factors for specific types of engine, it also allows us to calculate the pollutant emission of the operating machinery. Second data inputs is identification and localization of emission sources in the port that can be given by the port manager. The input needed is weather data that can be collected directly with the wind sensor available into the port. This map shows the results of the air pollution model from the port of Thessaloniki in Greece. The colored pin dots on the map of the port represent the concentration of sulfur oxides, and the red-shaped stand for the different source types. Pollution model will be implemented directly in the Pixel dashboard for Environmental Manager. The aim is to dispose of this tool to give real answer to operator and manager problematics. For example, I'm an environmental operator and I want to have prediction for the effect at the city by the air emission of cruise and passenger traffic. In the air pollution model, I can make a simulation with weather prediction for a specific period and with the specific activities of the cruises and passenger ships. It takes into account ship's call for the period and time at berth. Finally, I can have a map of atmospheric emission with the concentration of pollutant in the air from passenger traffic. That helped me to understand where and when port activities can impact the city air quality. It's finished for this model, but please take a look at the other Pixel Ports videos related to port activities scenario, energy consumption and prediction, and interland multimodal transport. Thanks.